Alright, this is 4.4 day 2, and today we're going to look at the mean value theorem. And what the mean value theorem says is if you had this function and it looked like this, and let's say this is the area underneath, and we made rectangles that were inside this function. Let's say this way, okay? Well, if I take this rectangle and go to the average, I want to do it the other way, I guess. I want to move him up. Oh no. I thought this would be much better than this. Easier. There it is. And if I take this and go to like half of where I'm trying here, folks, and I go half up and half down. Because remember, we had some that were underestimates and some that were overestimates. Well, what the mean value theorem says is that this was an overestimate and this is an underestimate, and they will be equal because we're going in the middle, or the mean, or the average. Okay? That's what the goal of this is. So that is, in a nutshell, what the mean value theorem says. When we had overestimates and underestimates, the mean value says, I'm going to take the middle of that. So there's a formula that we're going to follow for it. It means this. Lots of arrows. It says, the mean value theorem is the integral, or the area under the curve from A to B, where that this is going to be f of c times b minus a on some ab. All right? Always looks crazy. Let's do an example. So it says, find the value of c guaranteed by the mean value theorem of x cubed on 0, 3. So what I'm going to do is I'm going to do the integral, and I'll do it in red. All right? The integral from 0 to 3, I'm going to use this, 0 to 3, and I'm going to integrate x cubed. When I do that, I get x to the 4th over 4, evaluated at 3 and 0, which just turns out to be 81 over 4. Okay? Well, 81 over 4 is now, this 81 over 4 is now equal to f of c, okay, the function at c, times b minus a. Well, b minus a is 3. So we are going to solve for f of c. So I'm going to say that this is the same as 3 f of c's equals 81 over 4. This turns out to be f of c equals, divide by 3, 81, I guess, over 12. But now what's c? C is x cubed. Or I should say the function is x cubed. So that's going to be, implies, go to function. How's that? To give you some notes. Go to function, and this is going to be not x cubed, but c cubed. I know it's kind of technical, but it's going to be c cubed equals 81 over 21, and now take the cube root. So c equals the cube root of 81 over 21. Whatever that comes out to be, maybe 3 over cube roots of 4, whatever. All right? So that's the mean value. I mean, that's the c that I would find to make my rectangle, so half is above, half is below. Okay? Or I should say the areas are, you know, it's half the area, if you will, or the mean, the average of the areas. Okay, that is the mean value theorem. Not used a heck of a lot, all right? It's something you have to know for the AP exam. Next, used more, is the average value on an interval. So this is the average value of a function on an interval. And it's just the integral, but it's 1 over b minus a. So if we try to find the average value of this thing on 1 to 4, let's just plug and chug. This is not very hard at all. So this is going to be 1/3 of the integral of 1 to 4 of this thing. 3x squared minus 2x dx. When I do that, this is going to be 1/3, and this is going to be x cubed times x cubed minus x squared all evaluated at, I guess we're going 4 and 1. Okay. So when I plug 4 in, actually, let me not inundate you with arithmetic. This turns out to be 16. The answer for this turns out to be 16. And let me pictorially show you what it means. Here's our function. And if we're talking about area underneath that curve, at f equals, at that 16 point, the area on the bottom is equal to the area on the top. That's called the average value of a function at a certain interval. That makes sense. I like that one. Any questions? We'll do practice some of these for homework also. All right, we have some integrals. This is the definite integral. Constant a to b as a number. F is a function of x. Definite integral is a function of x. Notice what changes here. The big change is that x is one of our limits of integration, and this turns to a t. Well, a lot of times in physics especially, we like to differentiate and integrate with respect to time, because that's our acceleration, our velocity, etc. Second fundamental theorem of calculus. The second fundamental theorem of calculus says to do this. All right, we have, if I took the derivative of the integral from a to x, f of t dt, I get f of x. Weird, but because the x is there, that's what I get. This guy, and Chris, I'm talking to you, this guy is really, well, you know, this part is capital F of x, the integral, and this is the derivative. So this guy is the derivative of f, capital F of x, is equal to that. There are at least 5 questions on the AP exam regarding the second fundamental theorem. Let's do one. Once again, I think it's easier to do problems than to talk about the math behind it or where it comes from. Okay, integrate to find f as a function of x. Okay. Part A, we got to give you a function. So here's the original function. This is the original function. F of x equals 0 to x of t plus 2 dt. So that's all given. I'll do the rest in red, what you would start doing. So what I would do is, for A, this would be t squared over 2 plus 2t, all evaluated at x and 0. So I'm going to get x squared over 2 plus 2x equal to capital F of x. That's our integral. Plus c. I know there's a plus c in there. Bear with me. All right. You know what? Don't bear with me. Forget about it. Let me put it over there. Plus c. All right. There's your capital F of x. Now, that's part A. Part B says use the second fundamental theorem of calculus. And here it is, folks. Here it is. All right. We're going to take x and replace it in there. So we're going to get x plus 2. Okay? And then we're going to say, well, we're going to multiply it by the derivative of that top one. Well, it's 1. So the derivative of x, d dx of x, which is just 1. So you're going to get x plus 2 equals the derivative of capital F of x. Well, whoa. If I take the derivative here, what happens? I get x plus 2. So you can see there's 2 ways to do it. The second fundamental theorem of calculus, much easier to use than go through that whole process. Let's do another one. And I got to give you a nice function here. So let me give you a function in black so you know it's something that was given. It's not the third. I didn't make one up. It's the second. Okay. And the function, let's say, is f of x equals -1 to x square root of t to the fourth plus 1 dx. Or dt. Let's make that dt. Sorry. Alright. Now, this guy is still a constant. Make sure this guy is a constant, then we're going to do the Marashio trick, which is the second fundamental theorem of calculus. You take this, you replace x to the fourth plus 1 square root times dx, which is just 1. And that is this. Done. Let me show you where that dx, the derivative of this guy, is different than 1. So let's do a problem that looks like this. F of x equals let's do, ready? Let's do from 2x squared to 0 of 4t plus 1 dt. Well, one thing I have to do is have the constant at the bottom. So I am going to rearrange this like this. You're going to have 2x squared up here, 0 down here, 4t plus 1. That's using our properties of integrals. Now I'm going to use the second fundamental theorem. And the second fundamental theorem will say, replace. So I get 8x squared. I just plug this in for t. So I get 8x squared plus 1 times the derivative of this thing, which is 4x. And that becomes my answer. Alright? So I get 8x squared plus 1 times 4x. Perfect. You want to make that 32x cubed plus 4x. Perfect. And that is f prime of x, using the second fundamental theorem of calculus on this problem. Alright? So once again, the Marashio way to do it is you replace it and then take the derivative of the top. And you might say, well, what happens if you don't have, and all of these have to have a constant here. Oh, I forgot the negative. My bad. This negative has to come here. I'll put it here. So that negative comes over here. That's fine. What happens if there's not constants there? Well, then you might have to do it the old-fashioned way, as they say. Or you break it up. I'll show you that in class. But for now, I would like you to do some homework. I would like you to try some stuff. Homework. On page 293. Let's do 46 to 56 even. That's 10 problems. Alright, let me look at other ones. I have a lot more here, but let's see what they look like, please. I got 75 to 90. Let me see what these look like. Yes, yes, yes. You guys can do this. No problem. These are easy. Let's go 75 to 90. Now let's go less than that. Let's go 88. You know what? Let's go 75 to 86. My bad. All right. That's everything. That's the second fundamental theorem. That's the real gist of this lesson. Then you also had the average value, which comes up a lot, and the mean value, which comes up also. We had a mean value theorem, but that was for derivatives. This is a mean value theorem for integrals. So if there are 3 things to get from this lesson, it would be the first one, the mean value theorem right here. Okay? Then we solve for f of c and solve for c. The second thing you would do is get that one. That one I use more so than that one, and the second fundamental theorem I use more. This one, and then the second fundamental theorem of calculus. I like the Marashio way I talk about it down here. Okay, here's your homework once again. I'm sorry for scrolling so much. Enjoy, and I'll see you mañana. Nice.